Today we will take moment of inertia of some dynamic bodies. We will write only formula. Moment of inertia of some bodies. The name of body, axis about which we have to find the moment of inertia, and here is formula. Number one is hollow sphere. About the diameter. It is a hollow sphere. It is moving about this axis. Diameter. Its radius is r and mass is m. And I will be 2 by 3 mr square. Now the moment of inertia of a sphere about tangent. We can also say that the moment of inertia I will be 5 by 3 mr square. Number 2, moment of inertia of plate, rectangular plate. Number A point about the axis passing through the center of the plate and perpendicular to the plane of the plate. About the axis passing through center and perpendicular to the plane of plate. Means this one is any plate, length is L, width is B, it is rotating about this axis of rotation, its mass is m, and moment of inertia I will be m upon m L square plus B square divided by 12. This way we can find the moment of inertia about any axis passing through the corner of the plate and it is perpendicular to the plane. We want to find the moment of inertia number 2 about this axis. Next number is number 3rd point, cylinder. It is solid cylinder. About the axis of the cylinder, means we have to find the moment of inertia of this cylinder about this axis. Its radius is r, mass is m. We can assume this one is a disk. For example, moment of inertia of a disk is this one about this axis. Thickness is t. This one is t. The moment of inertia is given by mr square. Does not depend on the thickness. Thickness does not depend on thickness. So we can assume this cylinder as a disk. Moment of inertia about this axis I will be half mr square. Now the second point about the axis passing through the center of the cylinder and perpendicular to the length. About the axis passing through center and perpendicular to the length, means in this way it is cylinder, the length is L, the axis which is passing through this one, this length is L by 2, mass is m and radius is r. Okay. Rotating about this axis, the moment of inertia I will be m into r square upon 4 plus L square upon 12. The moment of inertia of the solid cylinder. In the same way we can easily find the moment of inertia of a hollow cylinder about the axis of the cylinder. Now, moment of inertia of a square plate, X number is this one is length L, it is also L. We have to find the moment of inertia of this rotating about this axis. Mass is M, then I will be M L square plus L square upon 12. That's I will be M L square upon 6. Now the rotational kinetic energy. Kinetic. Suppose an object is moving in this way, it is simply its motion is translatory. It means the velocity of the upper point will be v, that of center will be v, and that of the lower point will be v. It means the translatory motion. It is rotatory. In case of rotatory motion, the object is this one at the center. The velocity of the uppermost point, that will be v, or lowermost point will be v, but they will be in opposite direction. And the rotating about this axis, the rotatory motion. If we combine these two motions, then it is known as sliding motion. If we combine the combination of translatory motion and rotatory motion is known as rolling motion. That means this one is a translatory motion, it is v, is also v, this one is velocity v, plus it is a rotatory motion, this one is v, that is v, and it is moving in this way. We combine, it gives a rolling motion. It means the velocity of uppermost point will be v plus v, that's 2v. Its velocity will be 0, v is 0, and there is rotating about this point, and also v. It is rolling motion. In case it is translatory motion plus rotatory, it gives rolling motion. Now if we want to find the kinetic energy of rolling motion, then kinetic energy of, that is half mv square, kinetic energy in rotatory motion, that will be half I omega square. The total kinetic energy in rolling motion, kinetic energy in rolling motion, so we can say the total kinetic energy total, that will be translatory motion, translatory kinetic energy plus rotatory kinetic energy total, that will be half mv square plus half I omega square. Because of I is given by mk square and omega is v upon r, so we can also write kinetic energy total in the rolling motion. That will be half mv square plus half mk square into v square upon r square. We take half mv square as common, half mv square, it gives 1 plus k square upon r square. It is the kinetic energy total in the rolling motion.